All right, Biswa, thank you for the great introduction to AI in the data center. One of the things that I want to touch on just to kind of level set for the Samtec portion of the webinar was to expand upon generative AI, really what that means. Rich and I were talking a little bit before our webinar last week, just bounce an idea or two back in terms of what topic to open up with. And the thought process that we both came up with is, what's a good example of what is generative AI? That's a term that's kind of thrown about, rather easily within AI circles. And if someone's new to AI, that it may not make sense. The AI training, the AI inference kind of makes sense because you've got big data sets, you get models, and you run the data through the model to train it. But what is generative? If you think about the root of generative, you're generating something. All of us are probably familiar with ChatGPT. So a few days ago, I was preparing the slides, and I'm probably giving away where I live at by saying, draw me a picture of Jack Lambert. I'm a huge Steelers fan, so basically been born and raised in the Pittsburgh area. But if you look at the ChatGPT output of that statement, you'll see that ChatGPT tells you its limitations. It mentions that ChatGPT is an AI text model, so that the only generative AI that you can get out of ChatGPT is a chat or information. It is interesting, though, if you look through the answer that ChatGPT gives about Jack Lambert, it talks about his iconic toothless snarl. And if any of you are Steeler fans or just fans of football, NFL football from the 70s, that was one of the iconic covers of Sports Illustrated from the 1970s was Jack Lambert with missing two front teeth after the Steelers beat one of their opponents at the time. So ChatGPT is smart enough to realize that was iconic, or has enough knowledge base, enough data in its model to recognize that, but it can't produce the model. However, if you look at a new tool that OpenAI has come up with called Sora, this is an actual example from the OpenAI website, where if you come up with a description of digital art of a young tiger under an apple tree in a matte painting style with gorgeous details, the image that you see here is actually what their generative text-to-image tool comes up with. If you look on the OpenAI website under Sora, there's a ton of information and a ton of examples of text-to-video capabilities that their tool has. Now, you may sit back and say, great, I can use ChatGPT to find answers to all my questions. It's a evolutionary advancement from what search engines are able to do. And if I want to create digital art, I can use this new tool from Sora. What does that have to do with AI in the data center? Well, these two tools illustrate something that Viswa was mentioning, is that AI models are growing at an exponential rate. The size of the models are growing 10x, 100x almost every year. This is just a parameter, just a few snapshots in time. Elmo was one of the first large language models that became available back in 2018. It was put out by the Allen Institute for Artificial Intelligence, founded by the former or the founder of Microsoft, Paul Allen, before he passed away. And when that tool came out, roughly 6 years ago, it was groundbreaking for the time. It had roughly 100 million parameters. If you look at ChatGPT, if you look at Google's analogous tool, Gemini, those have roughly 100 billion parameters, maybe 200 billion, depending upon the metrics that you look at. So you can see within 5 or 6 years, massive growth in terms of size. Viswa also mentioned that the largest AI models right now have roughly, the largest number I saw in my research over the last couple of days, last week or so, was 1.6 trillion parameters. That sounds enormous, but when you think about the synapses the synaptic connections that we have in the average human brain, and I'm calling myself average with my picture up, we have 100 trillion synaptic connections in our brain. So for as large as these models are, they're still not large enough to even get onto the same scale of being able to mimic the human brain. The other thing, and Viswa touched on this too, as these models and as these data sets are growing exponentially, the power, not only from a energy standpoint, but also the compute power that is needed to process these large AI models and these large data sets is growing exponentially as well. I was at a trade show event last week, 2 weeks ago, and one of the presenters was actually joking that to instantiate next generation AI models in a data center stocked with the latest AI hardware architectures, you also have to put it next to an energy plant, whether it's a nuclear plant or hydroelectric plant. And everyone kind of laughed, but that also it validates the power numbers that Viswa mentioned in his presentation, where some of the latest AI chipsets, a single chipset, 1 kilowatt, 1.5 kilowatt, roadmap 2 kilowatts. You need hundreds or thousands of these things to process all this data. So the point comes up is, how do you connect all that data together? How do you route data from one, whether it's a GPU or an FPGA or a CPU? How do you route all that data from point A to point B? And that's really where Samtec comes in at. So from our viewpoint, when we look at artificial intelligence, we look at AI as one of the key accelerants of data center architecture over the last 5 to 10 years. And it's really become disruptive over the last 2 or 3 years, especially with the public's awareness around ChatGPT and some of the generative AI tools that we mentioned earlier. In addition to AI, obviously high performance computing, automotive 2.0, 6G networks. But AI is without doubt the largest catalyst in terms of data center system architecture going forward. What that also has forced upon the interconnect industry that Samtec plays a part in is to create a growing and diverse family of interconnect solutions that can route that data from point A to point B as efficiently and optimally as possible. So with AI, with data center, the interconnect companies are coming up with solutions that can work faster than the semiconductor companies can, because the days of choosing a connector at the end of a design are gone. As you'll see as we go through our part of the presentation, AI system architectures, AI hardware architectures within the data center are dynamic. They're changing. They have to be scalable. They have to be extensible. And the hardware architecture is purely dependent upon the AI chipset solution that you use. So something that's GPU based, the system architecture is going to be different if it's FPGA based. The system architecture is going to be different if it's NPU or TPU based or CPU based. And as we go through the presentation, we're going to talk about some of the interconnect options that Samtec has that is helping revolutionize AI system architectures within the data center. What does some of that look like? This is a snapshot of all of Samtec's bleeding edge interconnect solutions from the front panel to the back plane. We could literally spend hours or days going through all of our interconnect solutions in detail. We'll cover a handful based on some of the AI system architectures that we're seeing prevalent within data centers right now. But the point is that Samtec offers what we call silicon to silicon connectivity solutions that are ideally suited to route data optically, copper, or RF from point A to point B that meet or exceed industry standard demands. And then we back that up with design and support with our field applications engineers, our AEs, and our technical specialists, offering full system optimization so that when an AI system designer has to scale their AI system architecture, they can be confident that the solutions that Samtec offers helps them to do that. So because we're talking about AI in the data center, we're going to focus in on two applications. One, and this is something that Viswa talked about with the vector path accelerators. What is an AI accelerator? What's it do? And what are some of the form factors that it takes? Well, as Viswa mentioned, accelerator is used to accelerate parallel compute workloads common within AI and machine learning. Similar to vector path, AI accelerators typically have industry standard form factors. PCIe ChemAIC, which is what the vector path uses from Acronix, very popular. We also see solutions that use PECFF, M.2 for those that are familiar with the PCI SIG ecosystem, et cetera, et cetera. The concept of accelerated computing 10 or 15 years ago was really attaching an FPGA next to a CPU, an x86-based PCU. So these acceleration platforms have a history within the FPGA ecosystem, and again, Viswa mentioned that. But with the advent of so many different AI chipsets in the industry, GPUs, TPUs, CPUs targeted towards AI, new solutions, analog compute, there's any number of solutions out there. The AI chipset manufacturers have also started to develop their own AI acceleration platforms. And when you start to look at a survey across the market, there's any number of form factors or solutions that are out there. And as Viswa mentioned, the acceleration platforms are doing their job. They're delivering dramatic acceleration across a broad set of applications, generative AI, inference training, whatever the case may be. And they're also adding to efficiency within data center operation because the acceleration platforms are reconfigurable to provide an ideal fit based on changing workloads. No, not everyone is running ChatGPT instantiations 24/7. You may have a demand. You may be doing text to video on a spot basis, and you want to construct your AI system architectures to be able to handle those workloads when they're needed. So this illustration on the right hand side actually is an emulation platform that Samtec designed to enable chipset vendors and AI system vendors like Acronix to test the interconnect performance on their system using an AI infrastructure. So we'll talk about some of the interconnect solutions that we offer that complement AI accelerators going forward. So we talked about how AI acceleration platforms use PCI SIG ChemAICs, and this probably sounds standard. Okay, Samtec can make PCI Express connectors. We do, but we want to make sure everyone's aware of the diversity of solutions that we offer. At PCI Express 3.0 or 8 gigabit per second, we've got right angle, we've got vertical, we've got edge mount. For PCI 4 at 16 gigabit per second, we introduced a low profile version. We actually worked with a customer that said, I need to stay within the PCI Express form factor, but I need an extra 3 millimeters on my ChemAIC. Can you come up with a custom connector that will lower the profile while also giving me the same SI performance? And that's really what our PCIe LP was able to do. We have that also not available not only in PCI 4, but also in PCI 5. We're working on PCI 6 with 64 gigatransfers per second. We get a lot of questions about, well, where's your PCI 7 connectors? Well, the PCI 7 base spec is not going to be available until next year. And Samtec, like so many of the PCI SIG members, are working in parallel through PCI SIG to develop the solutions that will conform to the next generation of PCI 7 performance when that becomes available in the future. In addition to our PCI Express connectors, we also have a variety of PCI Express jumper cables. Currently, we support PCI 3 and below, PCI 4, PCI 5. We're working on PCI 6. Again, this is not something that's going to go into every data center hardware implementation, but when engineers, when system designers, when system architects are developing their system, working in a lab, sometimes you want to have a AI accelerator sitting by itself, maybe on a shock and vibe table or in an environmental chamber, and you still want to link it to your test platform or your compute engine. So using these jumper cables is a great way to isolate the AI acceleration platform from the motherboard, if you will. And that's a very viable. We get tons of requests for these types of solutions. And as PCI 5 is now native in a number of compute solutions available on the market. PCI 6 is going to become natively available in the near term. And as PCI Express implementers, especially in AI applications, start to use the interface, these type of prototyping tools, these type of develop and evaluation tools are pertinent. The other nice thing is we can customize the length too. We have industry standard lengths, but if you need something longer or shorter, we can work with you. It supports, we have cable solutions that support all PCI Express configurations by 1 by 4 by 8 by 16. We can put edge cards on both sides. We can put an edge card and a connector on either side as well. We also get requests from companies say, I need to test the PCI Express signals coming out of my connector, out of my CHEM connector. What do you got? Do I cut this cable in half? And the answer is no. We actually have test cables available too that can plug into a CHEM connector and that are terminated with an RF connector coaxially, so that you can actually plug that into your test equipment, whether that's a VNA or an oscilloscope or whatever. I didn't put a lot of detail that in the presentation, but it does cover. That's something that we do cover. People are eagle-eyed and say, that's great for PCI Express. What about for some of the higher speed signals that come with EDSFF or OCP NIC 3.0 or whatever? That's where our generate high-speed edge card system comes in. Generate is compliant to the SFFTA 1002 spec. We have the various 1C, 2C, 4C, and 4C plus form factors. This solution can support 64 gigabit, PAM4 for PCI 6 and CXL 3.0. We have vertical and right angle cable launches. And you can see that we also have a rugged latching system as well. This system has become very popular within AI acceleration platforms, and we anticipate seeing increased interest with this as AI acceleration platforms continue to proliferate within the industry. Something else that's very popular, we've seen with a number of our AI customers, top of card connectivity. If you see this with NVLink, you see this with other communication protocols within an AI hardware system. We've worked with customers to design in our Accelerate Slim Direct Attach system using our Accelerate cable to perform top card connectivity in an AI chassis. So we can support 8, 16, or 20 differential pairs in this 2-row design. It supports 64 gigabit PAM4 for PCI Express 6 or CXL 3.1 capability. It's very thin, roughly 7 millimeters wide, and then on the right angle, it's about 5.5 millimeters off the top of the PCB. So those are the solutions that we have so far for AI accelerators. The other solution we want to talk about briefly is our domain-specific architectures. This really gets into the heart of the AI the AI system architectures that we see in data center. A good example of that, if any of you have been paying attention to some of the news on the AI market, NVIDIA just introduced their Blackwell platform. Blackwell is completely different from previous versions that NVIDIA's put out. And a lot of that is just goes to prove that the hardware design of the system is optimized to get the most data throughput with the least amount of power in the small density solution. And having flexible, scalable interconnect is essential to be able to achieve those types of results. So Samtec offers a number of solutions there. We're just going to kind of run through them because we're running a little bit behind. Our Accelerate HD solution is a 0.635 millimeter pitch edge rate contact. It's a 5 millimeter body width, various stack heights. The reason that we mentioned here is because Accelerate HD is very popular on a number of AI system on module platforms on the market. It does give you access to PCI 6 data rates at 64 gigasample per second, or 64 gigabit per second. Its bigger brother is the Accelerate HP. The only difference between the HD and the HP is the fact that we add some additional space between rows 2 and 3. What that allows for is additional grounding, additional it simplifies the routing capabilities of the differential pairs up and down the size of the connector. So by adding that additional space, we can actually increase the data rate from 64 on the Accelerate HD all the way up to 112 gigabit per second as well. We're also looking to test this at 128 gigabit per second as silicon and solutions become available at next generation speeds. Again, Accelerate HP is also very popular on a number of AI system-on-module solutions. To achieve the best results for routing data within AI system architectures in the data center, typically you take the signal out of the PCB and put it into an ultra-low skew twin-ax cable to route the data over longer distances. Why do we do that? In general, twin-ax cable has about 1/3 the loss of PCB materials, even advanced solutions. So Samtec offers the widest variety of cabled interconnect in the industry. For front panel applications, we have flyover QSFP systems that support 800 gigabit per second per port, up to 1.6 terabit per second per port on some of the solutions we're working on. We support industry standard MSA, QSFP, QSFP-DD, QSFP DD800. We're working on 1600 for next generation solutions. We're also looking at flyover SFP 112, OSFP 112, and OSFP 224 for next generation AI system architectures. Terminating the cable from the front panel to an ASIC adjacent solution is where we make our name within the industry. Our Accelerate HP extreme density system is used on leading AI platforms because of its performance per channel, but also its increased density. You can see that in a very small space, we can get up to 72 differential pairs. We're working on increasing that to 96. To give you an example, looking at a 35 millimeter by 35 millimeter footprint, we can get two of our Accelerate HP connectors onto the PCB, allowing for 144 different total differential pairs within that small area. In working with one of our key vendors, they've asked us to double the density. So the next generation solution that we're working on right now is our Accelerate HP Gen 2. You can see in the graphics here that by optimizing the pin placement within the interconnect, staggering the row to row spacing, we can actually double the density. So within the same footprint on the previous generation, 72 differential pairs, we can get up to 144 differential pairs within the same connector. So when you're looking at a signal density, it's 182 differential pairs per square inch, supporting 112 gigabit per second per channel. Another solution that we offer that's ASIC adjacent but low profile is what we call our SciFly LP. This is targeted at sitting next to an ASIC solution. You'll notice that it has a very low profile, 4 millimeters. That allows the system to abut the ASIC on the system while also being small enough to sit underneath the heatsink. When you're dealing with AI system architectures or AI chipsets that have 1 kilowatt, 1.5 kilowatt, 2 kilowatt TDPs, it's essential to provide as much surface area, not only in the chip but also in the system architecture, to eliminate that heat. And the SciFly allows you to extend the surface area of the heat of the thermal relief larger than the actual size of the chip. The latest solution that we're working on and we're real excited about is what we call our SciFly HD. SciFly HD is our first ASIC adjacent 224 gigabit per second interconnect solution. In a small 14 millimeter by 14 millimeter footprint, you can get 64 differential pairs. This also allows for the highest density interconnect solution that we offer, 245 differential pairs per square inch. And one of the reasons we're able to do that is because of the next generation high-speed air twin-X cable technology we have that makes the twin-X cables roughly half as thick as previous versions of our patented high-speed technology. This also goes to show that this is not just an interconnect solution. SciFly offers co-package applications whether directly on the substrate or directly on the package. The system is scalable, flexible. It's also been designed to enable thermal relief, whether that's passive, active, or liquid cooled. One last technology we want to introduce. We're seeing a ton of interest within the ecosystem for AI for PCI Express and CXL over optics. Samtec is the leading provider of midboard optical transceivers within the industry. Our current Firefly optical flyover technology offers data rates up to 28 gigabit per channel with a roadmap to 32, which we should have available here in the next couple months. We also have a next generation platform which provides a roadmap to 56 and 112. Both of our Firefly and Halo solutions are protocol agnostic and are proven to work with PCI Express, CXL, InfiniBand, Ethernet, and a number of other popular protocols typically found in data center and AI applications. So key takeaways from our presentation. Samtec offers a comprehensive portfolio of high-performance interconnect solutions for AI system architectures. We have a global team of SI technical experts, AI technical experts, online design tools, and world-class customer service to help design in these interconnect solutions for AI system architectures. We've also developed a new AI interconnect solutions guide, which goes into more detail about these and even more interconnect solutions that we talked about. And for more information, you can visit our website at samtec.com/AI.